Assalamualaikum and good day to everyone. Today, I would like to share my research project on MOS2GO catalyst. My name is Izian Najwa from UiTM Negeri Sembilan and I am supervised by Dr. Siti Nur Atika. Let me introduce my team members.
In brief, MOS2GO catalyst will be used in photocatalytic degradation. This is the graphical sketch for presenting the process of photocatalysis. The objectives of this research project is to design a phototreatment technology for photodegradation of perfluorooctanoic acid.
MOS2 is a 2D photocatalyst semiconductor which has narrow band gap and powerful invisible region. When photon from light source bombarded to its valence band, the electron will be excited to the conducting band. The fossil for charge recombination create the idea for GO as a helper and supporter for MOS2. The excited electron at conducting band MOS2 will not return to the valence band as the presence of GO will make the excited electron jump to its conducting band. This is because GO consists larger specific surface area and good electron transfer abilities. Then, electron at conducting band will react with oxygen to produce superoxide radicals or hydroperoxide radicals, and this species was used to degrade organic pollutant, which is PFOA. PFOA is a very stable compound due to fully fluorinated, which not fossil to decompose naturally. A few techniques was discovered and photocatalytic degradation, one of the best technique due to green technology and cost effectiveness. There are some problems arise was discovered during this research. PFOA was widely used by humans such as in paint, pesticides and fire foam. This high exposure can cause harm due to its toxicity. The other problem was the lack of MOS2 properties which produced the heterojunction photocatalyst idea. In order to enhance the properties, MOS2GO catalyst is very powerful combination that active in visible region. Meanwhile, PFOA active in UV region. Thus, MOS2GO created a novelty as it can degrade the PFOA. This research is aligned with Sustainable Development Goals number 6, which is for clean water and sanitation, and number 7 for affordable and clean energy. Proceed to the methodology to produce MOS2GO catalyst. MOS2 was synthesized by hydrothermal reaction where it using higher temperature and higher pressure. It run under sealed pressure vessel which using Teflon steel. Hydrothermal method is one of the technique in order to produce crystallizing substance.
Now, let us take a look on the typical process of MOS2 synthesis via hydrothermal method. Typically, 1.5 gram of sodium molybdenate and 1.9 gram of thiourea was dissolved in 20 ml of deionized water and then sonicated for 30 minutes. The pH of the solution was then adjusted to 2 by adding 1 molar of hydrochloric acid solution. The reaction mixture was then moved to hydrothermal treatment at 180 degrees Celsius for 24 hours. The resultant product was then centrifuged at 4000 rpm for 10 minutes, washed several times, and dried for 12 hours in a vacuum oven at 60 degrees Celsius. For storage, the completed product was placed in a desiccator.
Next, graphene oxide will be synthesized by using modified Hammers method. Modified Hammers method will generate GO through oxidation of potassium permanganate to a solution of graphite, sodium nitrite, and sulfuric acid.
Next, we move on to the synthesis of graphene oxide via modified Hammers method. Typically, 0.5 gram of sodium nitrate, 1 gram of graphite flakes, and 23 ml of concentrated sulfuric acid were added in a 250 ml 3-neck round bottom flask, which stirred at room temperature for 1 hour and kept in an ice bath. Then, 3 grams of potassium permanganate was added slowly for 1 hour and stirred vigorously. The ice bath was then withdrawn and the solution was agitated for another 4 hours. The temperature of the solution was then raised to 35 degrees Celsius using a water bath and it was stirred for another half hour. After that, the suspension was put into 250 deionized water and heated to 70 degrees Celsius and was stirred for 50 minutes. The addition of 30% hydrogen peroxide solution eliminated the unreacted chemicals. The graphene oxide was obtained by centrifugation and washing with 5% HCl solution several times. Finally, the slurry was dried overnight in a vacuum oven at 70 degrees Celsius.
Then, The reaction will be proceed to synthesize MOS2GO catalyst. MOS2GO catalyst will be synthesized by ex-situ techniques and the final product known as 15% MOS2GO. All the synthesized catalysts will be proceed to photocatalytic degradation process. The photocatalysis will be take place in the photoreactor. The PFOA and the catalyst will fill in the chamber of the photoreactor. The photoreactor help to standardize the power of light to each catalyst. After the photocatalysis, leave for 1 hour, the degradations of PFOA will be analyzed by HPLC. In conjunction to confirm that synthesis was successful and the integration had occurred, MOS2GO and 15% MOS2GO was characterized using FTIR and XRD. Based on the FTIR results, all significant peak of GO was appeared at 1734, 1159 and 1579 that represent the carbonyl, epoxy and C double bond C stretching mode respectively. Meanwhile, MOS2 peak was observed at 862, 1415 and 1617. Overall, all the characteristic peak of MOS2 and GO were present in the MOS2-GO composite, hence proving the integrations of GO in the MOS2 layer. Based on the XRD results show that GO are exhibit in amorphous structure. Meanwhile, MOS2 exhibit the crystalline pattern and the significant peak was observed at 14 degree and 35 degree. However, the incompression of MOS2 in GO decreased the crystallinity of MOS2 due to its low loading contents. Thus, it showed that MOS2 and GO were composited fairly well in the composite materials. The screening results showed the differentiation of each photocatalyst where 15% MOS2GO showed the best degradations of PFOA. Then, the best catalyst in screening result will be proceed for optimization process. The optimization will be determined using 3 parameters which is pH, amount of loading, and contact time. In the conclusion, it showed that pH2 20 mg of amount catalyst and at 120 minutes showed the best parameters for degradation of PFOA. All the best optimization parameters was used in catalyst performance of reusability. Thus, the catalyst can maintain its ability up to 6 cycles.
To further acknowledge the accomplishment of this technology has been published in Journal of Environmental Chemical Engineering Q1 with impact factor of 7.968. Title for the journal was Photocatalytic Degradation of Perfluorooctanoic acid PFOA via MOS2RGO for water purification using indoor fluorescent irradiation.
This research was sponsored by FRGS grant. A special thanks to Faculty of Applied Science of IITM Negeri Sembilan in providing all the required chemicals and instruments. Thank you for watching.